Hi, and welcome to Module 2 of Mechanics of Materials Part 1. Today's learning outcomes are to first calculate the internal forces due to external loads applied to a real-world engineering structure, and then to classify what we're going to call axial-centric loading. So I showed this general outline of the analysis approach we'll take in the course. We start with an engineering structure, and this is a lot of review from my course, Applications of Engineering Mechanics. The structure we're going to look at is, in this case, a truss bridge. And back in modules 8 and 9 of my Applications in Engineering Mechanics, we analyzed this by doing first a free body diagram to show external loads being applied to something like the truss structure that I have here. And we cut into that structure and found the internal forces and moments, if there are any, in each of the members of the structure. And now we're going to go on and from those internal forces and moments look at stresses and strains developed in the member and evaluate structural performance. Is the engineering structural member going to perform as we would like it to do? And so we're going to start by applying axial centric loads to these members. And so here's our section cut of the truss showing whether each member is in tension or compression and what the magnitude of that force is. I'll show it as a round cross-section at this point, but the cross-section can be square, it can be rectangle, it can be an I-beam, as long as we just apply an axial load. And by axial loading, I mean that the load is parallel to the longitudinal axis of the member, and the loading is centric, which means that the line of action of the resultant force passes through the centroid of that section. And so that's where we'll get started in the next module.